Hi there and welcome to Mr. T's Maths. In this video I'll be showing you how to find the length of a line by working out the distance between two given points. And we will be doing this by using Pythagoras' theorem. So let's see how we can find the distance between 2 points. Here we have point A with coordinates 2, 1 and point B with coordinates 4, 5. Now, in order to find the distance between A and B, or the length of this line A and B, we have to first construct a triangle, and we do that by drawing a horizontal line from this point A parallel to the x-axis. By the way, these are the x-axis and that's your y. Okay, and then a vertical line, make sure it's straight, parallel to the y-axis, as I've done here. As you can see, we have constructed a right-angled triangle. If you take a close look at the base of the triangle, you can actually work out that the length of this base is the difference between the x-coordinate of B and the x-coordinate of A. So the base here, I'm going to use B to denote the base, can be found by subtracting the two x coordinates. So 4 minus 2, which leaves us with 2. So the base is 2 units long. Okay, then the height of the triangle, is actually given by subtracting the two y coordinates. Okay, so 1 and 5. So we can find the height by subtracting 1 from 5. So 5 minus 1 is 4. And the height of this triangle is 4. Okay, now we can apply Pythagoras' theorem. Okay, so AB squared equals to this side squared, 2 squared, plus this side here, which is the height, squared, 4 squared. So AB then is equal to the square root of 2 squared plus 4 squared, which is square root of 4 plus 16, which is square root of 20. Okay, and just to keep this more accurate, we are going to leave it in this format. Okay, but you could just type this in a calculator and write down the answer as a decimal. Okay, so the distance of AB is square root of 20. Now I would like to ask you to think of the actual process. What have we done here? And we can actually come up with a formula for this distance, right? I'm going to use, instead of AB, I'm going to call that the distance. So D equals, and you see that we've worked out that distance was the square root of something. Of what? Well, this 2 squared. But how did we get the 2? We found 2 by subtracting, if we take a look at this, by subtracting the x coordinates. Okay, if that's your x1 and that's your x2, we found that by subtracting the 2 x coordinates. That's how we found the base. So this is actually equal to x2 minus x1, everything squared. Then we've added 4 squared, and 4 was from the height here, which was found by subtracting the y coordinates. So y2 minus y1, which is squared. Yeah, so there you go. This is a formula that you can use, so you don't have to always draw this out. okay, you can go ahead and use the formula straight away. But basically, this is where the formula comes from. I hope this graphical representation helped you to understand where the formula comes from. And now I would like us to put this formula to practice. So let's go ahead and do some examples. So let's go ahead and try using the formula. We have an example where we want to find the distance between these 2 points A and B. Now the formula is, as we said before, x2 minus x1 squared plus y2 minus y1 squared, and then we do the square root of all that. Now I would just annotate these coordinates here. I'll choose A to be my x and x1 and y1, so x1 y1 and then x2 y2. So what first, use this technique, okay, to avoid making mistakes. Eventually you won't need to use it anymore, but yeah, it's a good technique to just reduce the probability of making any errors. Yeah, so x2 in this case is 2 minus 8 squared plus y2 is 6 minus 1, 6 minus 1, which is squared. Then we take the square root of that. Now d equals 2 minus 6. As you can see, we have a negative answer, minus 6. Oh, I meant to say 2 minus 8. There, 2 minus 8, okay, squared, plus 6 minus 1, which is 5 squared. Okay, now minus 6 squared is positive 36, so everything is raised to the power of 2, plus 25, and we take the square root of that. Okay, so d equals to the square root of 61. Actually, we don't need to draw that so long. Yeah, so square root of 61, and that's our answer. Okay, now we can use this graphical representation quickly just to show you that what we've done here is correct. Yeah, so let's say we plot point A, which has coordinates 8 1. Okay, so that's about there. Then point B, x coordinate is 2 6, so let's say about there. Okay, and we want to find this distance. We construct our triangle. Let's not forget to put that 6 there, or right angle triangle. Now the base of the triangle is 8 minus 6. Yeah, it will be 6 units long. 6 minus 1, then the height is 5 units long, right? And this here will be the square root of 5 squared plus 6 squared, which if you look here you will get the same answer. Yeah, so therefore it is definitely correct. I mean, it's up to you what method you want to use, okay, but well, I've given you the formula here. If you don't remember the formula, just use the graphical representation. It's straightforward. Yeah, okay, so I have one more example. Don't hesitate to pause the video and try this yourselves. Okay, so we're going to first do this using the formula again. Square root of the whole thing, x squared, x2 minus x1, everything squared, plus y2 minus y1, everything squared. And let's clarify which one is which. We can take this to be x2 if we want. It doesn't matter, as I said before. That's our x1, and this is y1, so that's y1. Okay, so we have x2 minus 5 minus 5 minus minus 3, everything squared, plus y2 1 minus 1 minus from there, and then y1 is negative minus 4, everything squared, and we have to take the square root of the whole thing. So d equals 2. Now this minus minus is a plus, yeah, so let's just clarify that. That's a plus. Minus minus here is a plus, so the answer will be minus 5 plus 3, which is negative 2, everything squared. Be careful when you put this in the calculator, you have to use brackets because it's minus 2 times minus 2. Okay, so your answer will be positive. 1 plus 4 is 5 squared. Okay, so d equals to 4 plus 5 squared is 25. Okay, square root of that, and eventually d equals to square root of 29. Now I'm not so bothered about working that out. You can do that using a calculator if you want to. I'm more worried about the process. I want you to understand the process, right? Okay, square root of 29. And as I said before, we can easily use the representation method to draw the triangle and see that this is actually correct. Let's go ahead and do that. First of all, we have point A, which is minus 5. So minus 5 can be somewhere here. Minus 5, 1. So A is there. That's 1. And then minus 3, minus 4. Minus 3 and minus 4. We can say that's B, minus 3 and minus 4. That's our point B. So we want to work out this distance there. Okay, we construct our triangle that way. Perfect. And we can see that this length here is from minus 3 to reach minus 5. There are just 2 units, so it's 2 units long. Alright, and then from 1 to minus 4, well, think about it, from 0 to minus 4 there are 4 units, and from 0 to 1, 1 unit, so that means the whole of this will be 5 units long. Therefore, AB is going to be equal to the square root of, okay, this squared plus that squared, so 2 squared plus 5 squared, which is eventually square root of 29, and there you go. Okay, so I hope you found this video useful. Don't forget to subscribe if you haven't done so already. Do learn your formula, but don't worry if you forget, because you can always use the representation method. Alright, take care.